Now, like I was just saying, there's basically, you can split it into these two things, these two different kinds of pipelines. Your pipeline for infrastructure and your pipeline for deploying software on top of the infrastructure. The tools that we're going to use to build out the pieces of the diagram basically can be classified into different kinds of tools, okay? And the basic classification scheme here that's going to be important for us is whether or not a tool is declarative or procedural, and whether or not a tool is agentless or has a server agent component, okay? And in general, you always need to be aware that declarative is always better than procedural. And so what do we mean by declarative and procedural, and why is declarative better than procedural? So procedural is basically anything in computing where you have a list of basically linear tasks that happen one after another. First you do this, then you do that, number two, then number three you do something else, number four you do something else. This is procedural. And so there are many things in the computing world that are procedural. Like if you write some code, perhaps in Python, with some for loops and some steps, step by step, what the code is going to do, that falls into a procedural category. Do this first, do that second. If the second thing depends on some other thing, then do this, a lot of if-then statements, that kind of thing is what we mean by procedural. So in this diagram of tools that we can use, some things are procedural and other things are what we call declarative. So declarative is a different way of thinking or approaching a problem. Declarative means that you specify somewhere, and usually the somewhere is going to be a file, a YAML file or a JSON file, a template file, something like that. So in a file, you specify all of the attributes of the final state that you want something to look like. Final state that you want something to look like. And that something is usually going to be a resource, a computing resource of some kind. And that resource is usually going to have, some configuration that's associated with it. So in this declarative approach, you are specifying a static file where all you're doing is you're saying how you want that resource to look like, the final state of that resource. And you're letting the tool or whatever, external thing, tool, program, whatever it is that you're going to be using, you're going to feed this declaration into that tool, and that tool is going to set it up and make sure that the resource achieves that final state, gets configured into the final state. Okay. Now, some of you, like in the last time I taught this class last month, we had a couple of people who brought up a very good point, which is, well, wait a second. How do you get to that final state? Isn't the process of getting to the final state a procedural process? And the answer is yes, it's a procedural process. So the difference here is simply whether or not you, as the engineer, are writing up that procedural process yourself, or if you're relying on another third-party tool to take care of it for you, and you're depending on them to do the procedural stuff under the hood, where you don't really care about how it's done. You don't care about how they wrote it or what it's doing. All you care about is that the final state is achieved the way you are wanting it to be achieved. So the difference between the two approaches is that you, as an engineer, on the left-hand side, all you're writing is the declaration here. Or you, as the engineer on the right-hand side, you're actually writing all the procedural code to do something. So that's the major difference there. And the reason why a declarative approach is much better for those of us SREs that are involved in setting up infrastructure as code and CI/CD pipelines. The reason the declarative approach is much better is because many reasons. It is much easier to maintain. It's easier to see what the final results should be. And it's easier to prevent long-term drift in the environment from happening. And what we mean by drift is you set up an environment on day one. Okay. Well, as we all know, especially those of us who've been working in this field for a while, we all know that, things can get out of whack over time. You might be deploying 10 servers initially on day one, and then like a couple weeks later, you need to deploy a couple more servers, but you have to do it fast because, they need them real quickly. And so you might say, okay, well, let me just manually do them real quick. And then later I'll add them to the code, but you might forget later, stuff like that. So that's what we mean by drift, is that over time, invariably in any environment, especially the larger environments, over time, your desired state is going to get a little bit out of whack with your actual state of the environment. And so using declarative tools makes it much easier to prevent that from happening. The reason it makes it easier is because if you're not using the declarative tools and you're using just the procedural stuff to define your environment and to create and set up your environment, as we all know, that's just a lot more code to maintain. And so it's much easier to not update things the way you should over time. It's much more difficult to actually look at this code and say what the final state should be, right? Because this right-hand approach involves a lot more lines than the left-hand approach. There's just a lot more stuff here. And so it makes it much harder for you to just look at it and say, well, yeah, that's what the final state of the environment should be. But is it really like that? It's much more difficult. So those are the main reasons why a declarative approach is better than a procedural approach. And therefore, when you're setting up environments in your workplace, you should always try as much as possible to opt for the declarative rather than the procedural. So you're going to be choosing a lot of tools you're going to be choosing from a lot of tools at your disposal to set up these pipelines. You might not use Jenkins. You might have other tools that you might be interested in, and so forth and so on. These aren't all the tools that are on the screen here. This is just a little scratching the surface of the different kinds of tools that are out there. And so you have to always look at which tools you're going to be using and try to choose the declarative ones rather than the procedural ones, because it's going to make your life a lot easier down the road. It's going to make everybody's lives a lot easier. It's easier to maintain the state. Now, the next thing we need to look at is the agentless versus server agent idea. And what we mean by that is, again, with all these tools at our disposal, some of them fall into a server agent category, which means that in order to deploy the tool, there is a server software component of the tool that you have to deploy onto an actual server, right? And there is an agent software, client. That's what we mean by agent, is client. Client software portion that you have to deploy onto the clients in your environment. And so what this means is you have to set up more stuff. You have to set up a server to deploy that. You have to deploy the software onto all of your clients. So there's more work involved there, and there's more pieces. You got server software, you got agent software, and you have to have the infrastructure to run those. The other option is an agentless type of deployment, or an agentless type of service. And examples of agentless type of services would be things that don't require agents, client software to be installed across all the hosts in your environment on your hosts. So just any service or any software that actually doesn't require you to go and deploy some client software across your whole environment in order for it to work. So of the two, obviously the agentless is more of the preferred type of category to try to achieve or try to use instead of the server agent software model, because simply it's just much more work involved with the server agent stuff and much more things to go wrong possibly. But now that we've talked about kind of the declarative and the agentless, now in the real world you have to just try to choose the best for your environment. So you're trying to prefer, it's just a matter of preference. You're giving preference to declarative and you're getting preference to agentless, but sometimes you have to make concessions. So examples of these. Examples of declarative are Terraform, Salt, and Puppet. Examples of procedural are Ansible and Chef. So just looking at declarative versus procedural, we're saying that we want to avoid using Ansible or Chef. And we want to prefer to use Terraform and Salt and Puppet. Now, a lot of you are going to say, well, wait a second, Ansible, that's very popular now. Everybody's using it, and people who aren't using it, they're trying to start using it. Everybody wants to go to Ansible. So I caution you against Ansible. The reason being that the more you work with Ansible and the larger your environment gets, it becomes much more difficult to make sure that Ansible is configuring everything the way it's supposed to, because it's a procedural tool. So instead of using Ansible, I highly encourage you to use Terraform instead. Terraform is a declarative language, and you're just declaring what you want the environment to look like, and you're letting the Terraform make sure that it does look like that. Now, examples of the agentless versus server agent. So agentless is Terraform. So again, another good mark for Terraform. It satisfies both declarative and agentless. Now you're saying, well, wait, now Ansible is agentless, and that's true, because Ansible, as you all know, is just a program that you run on one computer. So here's Ansible, you're running it on one computer, and it's connecting, it goes over SSH to 1,000 computers, and it does its work because it's connecting over SSH to a bunch of different computers. So that's agentless. The reason that's called agentless is because on these target computers, we don't have to install anything because they already have SSHD running. So we don't have to do any extra work to install like anything else. We don't have to install an Ansible client or anything like that on these computers. You just have to have sudo set up, SSHD running, and that's about it. And your access, So that's why it's called agentless. So the agentless satisfies, that we prefer agentless, but I'm going to still recommend against Ansible because the fact that it is procedural makes it worse than the fact that it's agentless. Agentless is a nice thing. It's less work to do, but the fact that it is a procedural thing means that its benefits are not as good as its disadvantages, So I'm going to recommend against Ansible. And the fact that you already have Terraform, which satisfies both declarative and agentless, means go ahead and use Terraform instead. Examples of the server agent model are Salt and Puppet. So again, you're saying, well, Salt and Puppet are good because they're declarative, but they're bad because they're server agent. And this is one of those examples where, one of those situations where, you just have to outweigh the pros and cons. So there's situations where it's going to be good to use Puppet, or good to have Salt in your infrastructure. And even though their server agent model, the benefits that they provide you are still could outweigh the fact that you have a little extra work to do to set them up. Okay.